Hello YouTubers, I'm making this video on the esp8266. I just picked up one package yesterday and I just wanted to give it a try, and I've been successful. I just want others to also learn from what I have in case they're having some troubles with the ESP. I had a couple of troubles initially, but I've been able to overcome them and it's just easy to use. I think it supersedes the ZB from Digital International, because this is just straight. It connects to your Wi-Fi and you can just do anything. You can put it in server mode or client mode or AP mode or whatever you want to put it into. And moreover too, it's very small, so it's going to fit on your boards without even realizing you have such a powerful wireless transceiver on it. Okay, all right. So in this case here, I'm using the esp8266 and I'm using the Arduino board. In my case, I'm using the Arduino Mega 2560, and we have a simple code running which is going to pull in the Arduino, which I'm going to make available publicly. If you want to use them, make some changes to it, it's up to you. It's free. There's no license attached to it. Okay, so we can see a couple of variables brought out there: the SSID, the password for the wireless router or the wireless network, the server IP. I want my client, I'm putting the ESP in the client mode, so the server I wanted to connect to and what I wanted to send, everything is going in there. So initially I put my serial for me to see what is being sent and received on the serial 0. For those of you using the Uno, I think you have to make use with the software serial, but the guys with the Mega, since we have up to 4 serials, I just decided to use 2 of them. So the first serial connects to the computer, and then the serial 1 connects to the ESP8266. Okay. There was a small problem I had, which I told you guys, with the software reset. I could reset it, but I couldn't have the module coming up, so I had to use the hardware reset instead, and it's been very successful and smooth. So what I did was I had to put a hard reset on the pin 7 on my Mega, and what you do is you put it low and you raise it high. It puts the device into reset, and once you reset the device, it's going to bring out a text telling that the device is ready. Okay, so I tell the serial 1 to read and find ready. Once it finds that, and that means the model is ready. If it doesn't find that and the model is off, then it tells the model not responding. Then it locks up with a while 1 there in a forever loop. But once the model is ready, then it's going to connect to the Wi-Fi based on the parameters we're going to set here, and I have a Wi-Fi connect function here, which is going to do that. You can still go through the codes and do that. Once everything is set up, you now need to send some packets, some data to your server to see how it's going to respond. You can send data to a website and anything and get a response from the website. So so I don't know what you will want to be using yours for, but basically it doesn't change any here. So here in the case, I'm going to use a TCP IP communication, and I tell the destination IP. I put a port on which the communication is going to go to, and then I send a command which I want it to go to. That means it's going to concat all these guys here, and it's going to put out the command there, right? So I want it to be printed on serial 1. That's going to the ESP, and I also want to view the command which is being sent, so that I'm sure of the command being sent. If you don't want this point, you can just comment it out if you don't need it in your code. Okay, once that is done, we see if there's any error. If it doesn't find error, I want you to send hello to my server, and it's going to send hello to my server. So once the data is sent, it's going to get the length of the command I want to send. It puts there, we're going to get a greater than sign there. Once that is done, it's going to send the hello to my server. It waits for 2 seconds to see if it receives anything. It doesn't receive anything, it comes down, it tells you it's done, send Wi-Fi. So this is going to be in a loop process. It's going to continue over and over, but it's just sending hello to my server. and I'm using the C++ 5.71. I just managed to write a small server in C++. Yeah, I'm still going to make this one available as well. So in here you can see here, I put some text file. I just wanted to create a text file for me. You can use that one for feature development, which I want to use that myself. Then I tell it to start a new server. I tell the server to run on port 444, and then once a client is connected, it should write client connected, and then the chat system should start. Basically, that's how all servers work. It's based on a chat. So we have data flowing out like that. Okay, so this is the real function for the server C file, C++ file, and then the server H file is here. You can make changes to them as and when you want them. So once this is done, so you can see my 444, that's the port I want to connect to, and this is the IP address of the server I'm connecting to. Okay, so once this is done, you can just download that one onto your Mega with the connections done properly. I think I just want to get the connections. Okay, with the connections, we have this ESP here. This light here is going to be blue when there's communication, and there's going to be our power LED. Once it comes on, that's when the ESP is on. Please, CHPD and RST here, reset here, we're going to connect the reset here to our pin 7, depending on which pin you decide to use. Initially I was tying it to VCC, but to use the software reset, but I was having issues. But I think it's best for you to do hardware reset. And then this GP IO0 is used for putting the ESP in programming mode. When put in programming mode, you're going to put it to ground. Yeah, you're going to put it to ground, and it goes to program mode. It can update the firmware on the ESP, but if not, you just leave it as it is. Okay. GPIO2 is not used. I think the rest, it just explains themselves. TX, RX, ground, and then VCC. Don't forget, the ESP doesn't run on 5 volts, it runs on a 3.3 volts. So if you're having a 5 volts, you will have to use a voltage divider to get it running. If not, if you already have the 3.3 volts, you can just use the 3.3 volts to power it. 5 volts is going to burn it up, and you're going to spend another $5 buying on one. Okay, all right. So I'm going to demonstrate what I have here. This is my compiled code, sorry, I used a double screen. This is my compiled code, and you can see it's running smoothly here. So you can see it's listening on port 444, waiting for clients to connect. So I'm going to power up my ESP. When it's off, I power up my ESP, and I'm going to turn up my cool term, connect to COM4, and I reset it. So let's see if it's going to detect the ESP. Okay, it tells me model is ready, connecting to Netgear 68. Let's wait. Okay, connected to Wi-Fi. It gives me my IP address of the ESP, and let's see if it can connect to the server. Okay, so you can see it tells you clients found, clients connected, and I start sending some data. Hello, and we can see the communication between the ESP and my server. So from here, you can just do anything. You can have a temperature sensor on the Arduino, which is going to send to through your Wi-Fi, and you can monitor that on your computer. You can have this in your hall, your kitchen, to monitor anything. And I think it's a great module esp8266 has done out there. Thumbs up for them. Shout outs for them. I mean, I don't know what to say, but I mean, it's beaten the Dig International ZigBee, which I always was kind of like thumbs up for them, but this one is extremely superb. Thanks for watching, and if you have any questions about using the esp8266 and your Arduino or any other microcontroller, let me know and I'm going to assist you. Thank you. Bye bye.